Okay, this is one of the greats. This is called the side splitter theorem. And what we get here is that if we have a line parallel, so we just did this in the other one. So if this line is parallel to the third side, right, we know that we will have, from the previous screencast, a small triangle similar to the large. So that's already all set. But this is going to be helpful because what we're going to say now, this theorem says that if we have that situation, right, where there's a parallel line, we're going to say that this piece relates to this piece the same way that this one relates to this one. It's a pretty cool theorem because it's going to be helpful down the road to be able to talk about pieces rather than the wholes. And you remember that I was careful in the other one to say what we knew. So here's the plan for the proof down at the bottom. Use similar triangles to set up proportions on the sides. So we already know that we have a parallel line in a triangle and it creates a similar triangle. So it's two sets of similar triangles. So we know, and I want to get this correct, we know that AB, oops, didn't mean to do that, AB, let's see if I can get this back, AB relates to AD, right? Hopefully I did this right. The same way that AC relates to AE. Now, hopefully people can see that, and that's related to the two similar triangles, which we already know about. Now, what's interesting is that AB can be rewritten. Does anyone remember what the segment addition postulate said? Well, that said that AB is made up of DB plus AD. And the segment addition postulate on the other side also says that EC plus AE over AE, right? So just stopping there for 1 second and saying that all I have done is rewrite AB this way, and I've written AC this way using the segment addition postulate, SAP, from the past. What's nice is that one of the rules back from ratios, we noticed and remember that, look what happens here. If I break these up, dB over AD plus AD over AD, right? If I use rules of fractions, EC, I don't really know what's happening there, EC over AE plus AE over AE, right? Now these are both 1, right? And so I can subtract 1 from both sides and I end up with dB relates to AD the same way that EC relates to AE, right? dB relates to AD the same way that EC relates to AE, right? The pieces are proportional. And that kind of makes sense to most people, right? That I can slide this parallel line up and down, and no matter what I do, the pieces that are created remain in proportion. That is called the side splitter theorem.